Sound looks good. Oh, where's my shut? Shut window is connecting. Connection is good. We have power. So test shut. Looks good. Let me open my what's happening? Looks like it's stabilizing. Yeah. Okay. Looks like we are good. What's happening with Hey Beanie! How are you, my friend? So, let's see what's going on. Oh, okay. Fusion. Close. Yeah, everything looks fine now. Connection is good. Connection is good. Okay, so it looks like everything is fine now. Yeah, I'm good. A little more rested today, which is good. Yesterday I was very tired. Okay, so good evening everyone, good morning, good afternoon, good day, good night, good whatever. How is everyone doing? I hope everyone is doing fine. So we are back to the CAM series. So we made some modifications, some card modifications to a CNC Milo V1.5. And now we are doing the CAM, so we can manufacture the parts on CNC mill. So people asked me if I could do the live programming, so we can find out how to program stuff, and that's what we've been doing. Yeah, my screen there, it's off because yesterday the power supply died, and to be honest, I completely forgot to look for a new power supply. And yeah, I know I have some, but I don't actually remember where. Let me check real quick if I have something here that could work. I don't think so. Yeah, it's just a 5-volt power supply with a USB plug, USB Type A. Never mind. So yeah, so we got some stuff today. So it's Monday. It's back to goodies day. So what do I got? So I got the shrimp father. Welcome. Hey Joseph, how are you? So I got the shims that I was talking about for the preload springs. So I got 0.1 millimeters and 0.2 millimeters. What did I got more? So I got a bunch of these connectors. So these are what they call aviation type connectors. I got a bunch of them, so I intend to replace the motor connectors with these thingies. And since I'm doing the enclosure, so first of all, so if you guys remember, the motors. Hey Diogo, how are you? So the motors don't actually have a connector, and the encoder of the motors have a VGA-like connector, so a 15-pin D sub or something like that connector, which is very bulky. Yes, these are GX12s, so these are the smaller ones. So I looked for the smallest form factor, because we don't need a lot of current on these thingies, so GX12s are the smallest. I also have GX16s on my other machines, and actually even bigger. GX25s, I believe, on my big machine. So this thing makes way smaller connector. You guys can see. I mean, the connector itself, it's long, but it's slim. And it's threaded. So there's no like weird, it's safe. It won't unplug by mistake. You actually need to unthread it to disconnect. I like this very much, so I ordered 4-pin for the motors, and 6-pin, I believe, for the yes, many machines use these at the controller box, or this type of connectors. So I ordered a bunch. I don't need as many as I ordered, but I use this stuff for other stuff as well. So I ordered more than I needed, and I want to. Oh, nice. And I need to. So I need to use them on the motor as well, and I'm gonna use them on the enclosure. No, it's gonna be Linux CNC or maybe I'll start with the Millennium OS to test it, but just to test, to be honest. But the idea is to go to Linux CNC. So yeah, I ordered, so these are 6-pin and 4-pin. So 6-pin for the encoder, we need 6-pin, so it's like something like, the encoders are simple encoders, they have no index. So it's just A plus, A minus, B plus, B minus, and 5-volt and ground. And it's way more modular. You can do a lot of stuff with Linux CNC. Of course not. Absolute encoders, the encoder itself costs more than I bought the motor and driver and encoder. Absolute encoder, it's just on my VMC. My VMC uses absolute encoders. 23-bit absolute encoders. Yes, because probably the ones you found are a 1/4 inch and not... What? Delta? Are you crazy, man? No, I'm gonna use cheap stuff on this machine. Why would I spend more on a driver than on the whole machine? I paid not even, I think it was like 65 bucks for motor and driver. Or you mean on my VMC? On my VMC I have some SG, I don't remember, it's the brand of the controller. So these thingies, so these are HBS 57H. And these motors, which are these guys. So as you see, it has a big ass connector. Okay, I'll take a look. Oh. Yes, these are DB15s. Oh, those things... Well, it has a... Yeah, those things are made for wood. Yes, they are 1/4 shank, so it makes sense it doesn't fit on your 6mm 6mm collet. And you see there's no plug on the motor, so I'm gonna use as well these thingies. And as you can see, there's a little difference on the connector size. So there's no point on getting this stuff. Yeah, I have some DMM drivers and servos, 400-watt servos on my router machine, and those things are beasts. Those things are fucking beasts, and they are the older model, not even the newer ones. They have a bunch of years already. They have more than 10 years already. Yeah, they have like 12 years now. But those things are beasts. And they are only like 400-watt servos. On my biggest VMC, I have 1 kilowatt servos, and those things are fucking beasts as well. Anyway, for Milo, this stuff will be way more than enough. So we're good. You're good. So what else? So I got this thingy, which is kind of important and cheap, and I don't understand why the Milo kit doesn't come with one. Well, I understand why, because the guys who designed the thingy know nothing about this stuff and didn't recommend it. So this is a simple EMI filter. So because VFDs do a lot of electromagnetic noise, these things are very handy for... Yes, it's a 4 kilowatt spindle on my router. It's a 4 kilowatt Chinese. So probably it's like 2.2 kilowatt. But yeah, so this thing is important for the VFD, and I don't know why, and these things are cheap. And even we should use, I have some, I'll show next, some ferrite filters on cable, on the motor cable. We're gonna use that as well. They are cheap. No, this one it's single phase because the VFD we're using it's single phase. So, and you want these before the VFD, not after the VFD to the motor. Okay, what more? I got the ball screws from the other supplier, and they look exactly the same. They feel exactly the same, which kind of makes sense since it was the exact same price. So let's open this one. I'm not sure which board. What do you mean, the controller board or the computer board? The controller board, it's gonna be a MES 7i96S. Yes, I'm gonna go FPGA. Yes. So ball screws, they feel very nice. I can feel any play on the. They run very super smooth, very oily. Okay, and actually these have a lot more gap, so they are not the same. So these need adjustment on the ball nut. So these will be a sensitive subject for the double nut configuration, since I see this is not consistent. So these have like a 1 millimeter gap. Let me see if I can. Well, 0.9 millimeter gap, while the others have like 0.1 millimeter. Well, kinda. But the main problem is you want the springs caged. So that slot that we made on the nut bracket helps with that, or it's for that, because you don't want, since the springs are very tight, the disc springs are So the disc springs are 12 millimeters. It have, oh, actually, yeah, it's close. It's close. Let me check something. It's not, it's... So the ball screw, even it's rated 12 millimeters. Well, it's the center of the balls that count, so, but the ball screw itself, it's 11.5 millimeters. And the disc spring hole is 12.2, almost 12.3, 12.26 actually. So you don't want the you want the springs caged. So that's why we made the that slot where the not a slot, a pocket where the disc springs are fit in, because you want them to be inside of that thingy. Yeah, they have to be centered by that. Otherwise, they can go and touch. They can move and touch the. Yeah. They can move and touch the ball screw, and we don't want that. So I'm pretty sure I'm gonna have to sell everything. So there won't be a possibility to like, oh, I'm gonna I'm gonna sell the kits, or at least if someone wants to source the ball screws by themselves, they need to tell me the size of the gap so I can modify the nuts. I'm not sure. Yes, they'll have to be. Hey Sven, how are you, my friend? Yeah, they have to be matched sets. So it's good to know. That's mainly why I bought from two different suppliers to check the differences. So yeah, but yeah, it's a good idea to have the ball screws first before making the kit. So I think the ideal is for me to just sell the kit. I'm thinking it should be somewhere around the aluminum parts, all of them, including the skirts. It should be about 400 euros, I believe. 400, 450 somewhere. Should be. I haven't done... I need to do one to evaluate the price. Oh, and yes, of course, we have the end blocks, the beer blocks as well. Everything looks good. Oh, nice. Let me try to... I haven't opened anything so on this kit, so let me take a peek to see if I can find, or if I can see what kind of... Oops, the music stopped. Because I forgot to... Who's bugging me on Discord? Let's see. Marcus! Welcome to Discord if you're watching our stream. Oh yeah, it looks like... Yes, it is... So we have... hey, no. Angle contact bearings as well. So the kits look identical, just the ball screw, the ball nuts. Let me check if they are all the same, since we are having this. At least we can check them all. Well, now on Discord you are Marcus, but here you are Maker US or Maker US. Let's see. Yeah, it's the same. About 1 millimeter. So beautiful machined, the end. Let's see how is the fitting on the block. Feels good. To be honest, the other ones feel better. It doesn't really matter. Yes, these have a little more clearance, but it's fine for what it is. You want the slide fit to be as slider as possible, as tight as possible without being too tight, but it's good. To be honest, I hate Mach 3. It works, but I don't like at all the software. It just works. I've been working with it for many years now, for like since 14 years, so it was since 2011. But I hate the software. I hate the damn thing. I love my Chinese controller. I love it. Even then, I wish I had Ethernet access. I have to be with a USB drive loading the programs. The new version, it's way better. But I love the controller, to be honest. I absolutely love it. No, it's a big ass controller. It's like an industrial controller, but it's Chinese. But it's super. It's I don't remember the name. I know it's 1000 MDC something. SZ. The brand is SZH something. I don't remember. But it's absolutely, I love it. I have all the interface, all the buttons. It could be a touchscreen, it isn't, but it's from 2019. Yeah, 2019. So, yeah. What more? So I have I said I tested my old epoxy to see if it was still good. I'm not sure. Probably the original properties are not. Yeah. On my Mac 3, I have a Ethernet smooth stepper. On Linux CNC, we can try parallel. I have parallel boards, and I have this guy here. I'm not sure if it will work, but that's something we can test. So I have this board that I bought in 2017 when I was thinking about making another CNC machine, which I ended up like a middleweight. So this thing is small. It's a mini ITX. It has a 8-ohm processor in it, and it has parallel port. It has a header in here, and actually it comes with the plug. So we can test Linux CNC with a parallel port. See ya, Beanie. Have a nice work. So yeah, it's a very small form factor. It's very cheap. This thing cost me $60 back in 2017, but now there's better options. So yeah, we can try this with Linux CNC without extra cost, because the Mesa card is expensive. Let's be honest. The Mesa card here in Europe costs about 200 euros with shipping. So it's not a cheap solution, but it's the best solution. So yeah, we can try. I actually have I bought these. I only started once to see if it worked, and it worked, but I assume it still works. Like I said, it was 7 or 8 years ago. It was in 2017. So it's making 8 years, I believe, in April. I have the invoice in there, but we can test with a parallel port. It's fine. We can make Milo. We should work with a single parallel port. It's only 3 motors and a few E-steps whatsoever. E-stops, sorry. And I'm gonna use a Raspberry Pi to add more I/O. That's something cool on Linux CNC. You can use a Raspberry Pi and add a shit ton of I/O. So you can have a very nice panel. I intend to do a nice panel for the. I like since I built my VMC and I'm used to the industrial controller. I like to have the buttons directly to mess with when the machine is running. So as I was saying, I tested my epoxy and it seems fine. I'm not sure if you guys can hear the noise. It looks like I'm meeting with a rock. So I haven't demolded it, but looks good. Super solid. This has been for more than a week curing. I just thought it would be fun. Let's demold one. Let me grab an old plier. So this is just a cap from a spray can. Oh, I said a Raspberry Pi? Sorry, I meant to say Arduino. I'm not sure if I said... Well, hook up the e-stop. You have the if you have the Mesa card, should be fine. It's solid, super solid. Imprinted the text from the... I'm not sure if I can show. Yeah, this thing is a rock. That indeed is super wet, so it's like a lot of epoxy and a little sand. But yeah, that's fine. This was with some of my spare sand of quartz sand. I actually have here. It was the bag I had laying around. I know it's kind of hard because I have too much light. Yeah, there we go. It's clean sand. You want clean sand. Something, yeah, pool filter sand. It's ideal because it's clean and it's a good grain size. So this one is as well because I made a lot of epoxy and I had to split into thingies. So yeah, pool filter sand is the best. Best, not the best, but it's the easier to find and it will work just fine. Especially if you can find two different sizes, two different grains, because usually they are, I know they are at least here readily available in 0.5 millimeter grain and 0.8, so you can mix the two and it's super duper fine. And I have another box which I haven't opened yet. I was waiting for the stream, so I'm gonna change to the top camera, which is a mess, but doesn't matter. So this is from the best sponsor in the world, from Lab 4450. It arrived today. And it's supposed to have some gifts. I have no idea. Well, I see many gifts of garbage. So let's see what we have. It's supposed to be my replacement. Yeah, so this is the replacement from LDO, the Nighthawk. So finally they made a revision and this is the replacement. So it comes with a tool head, which looks very nice. They actually glued the okay, so some important stuff here. Let's open it. Okay, so they glued the coolers, the heat sinks. The word was hard to come by. So they glued to that coil, and this one they glued it to the big ass capacitor. Nice. Oh, they actually installed it on the right way. So instead of installing on top of the ship people usually do, it's supposed to be installed on the actual PCB, and it is, so it should be fine on the TMC. We have room on the 2040 to do the same, to add a little heatsink there as well, which it will help. And this is the USB hub, I believe. And they have the heatsink as well. So yeah, looks good. And this is a new USB breakout board. Not sure what's different in there. So what else did the guy send here? So this is mine. I see he sent a ton of shit, which is good. Well, it came today, so it's here. So this is LEDs. So I make the XOL LED harnesses for Lab 4450 to sell. So he sent me the LEDs and the wire, and I make the harnesses. I solder everything and I send him for him to sell completed, because people don't like to solder very much, and I actually like. And the guy helps me, so why wouldn't I help the guy? Oh, an original CHT nozzle. That's the first one I ever had. So it's a CHT 0.4 millimeter nozzle. Cool, thank you. What's this? Oh, hot ends. A lot of hot ends. I'm going to open one. Well, it's the same as this one. I think. Pretty sure it's the same as that one in the bag. Nice. Yeah, so it should be exactly the same as that one. I'm not sure if it's the same or if it's the same as I have on my Styla. Oh no, this is the Triangle Labs version. This is better. This one is better. I had no problems. I have two of these on my Tridex. I had zero problems with it, but these ones, they drop like flies on my Skyless. On my Skyless. So yeah. Well, I have some in there that have no problems, but the others, my god, they drop like flies. Okay, so we gonna pretty much, I believe we gonna give these away on streams. No, I haven't seen that. I haven't been I haven't had paying I haven't been paying many attention to 3D printer stuff. Oh, actually to anything at all. So no time. Time is scarce on my end. Lot of feeling. Okay, I think that makes pretty much everything that I have to show today. So let's get back to work. Let me just take these away. Proskit keys. I have some stuff from Proskit. I usually use pliers from Proskit. What do I have more from Proskit? Where did you see in the Proskit? These are not Proskit, but I love this set. I think the only thing I have from Proskit is actually the cutting the flush cutters, the cutting pliers. Their stuff is good though. Near the solder stand. Yeah, I don't know. Not sure. This kit is awesome. Anyway, let's get back to my ugly face. Actually, let's go to Fusion. Let me close my personal Discord. And let's go to Fusion. Okay, so yesterday we did the nuts and the spindle brackets. So let me put that to the side. Yeah, the board, let me open Brave. Yeah, I think it's the 7i96S. I think it's what I'm gonna use. So 7996S. Yeah, it's supposed to be this guy. No, this guy is in stock. The 96 normal, it's out of production already. So the S, the only difference to the S, it's this one has the analog 10 volt output for the spindle. So yeah, this one it's supposed to be, it's the one I'm syncing. Now you were asking about one for Raspberry Pi. I believe they had one. Specific to... Is it this one? Yep, it's this one. Yep. And that this value is plus VAT if you don't have a company. So it will add 23% on, or actually it's from Germany, so it should be 21% on top, and shipping. And the dollar is a little bit weaker than the euro, so 100 euros should be something like $110. So and the stupid part is I was in Arizona where they are made in November, and I should have bought one there, and I didn't even thought about it. I need to check if some of my friends is going to the States anytime soon. But yeah, I think Ethernet is the way to go, because you can fit Raspberry Pi. It's also a good option, but I'm not sure if how good is Linux CNC on a Raspberry Pi. So yeah, and I'm not in the mood to spend money and then don't like it. So yeah, I'm gonna go just with this guy, with the 96, and get over with it. If I feel that's too powerful for the machine, I can always change it later to something a little less. This one looks good as well. I think this is a daughter car. No, it's actually same. The 97 is a beast. But yeah, I think the 96 it's kind of perfect for the Milo, up to 5 axes, which is awesome. Ethernet, so you can connect pretty much anything to it. Yep, the difference between the 96 and the 96S is just for the S, it's for spindle. So it has the analog output 0 to 10 volt for directly for spindle, while the 96 doesn't have that. The 76 was a beast of a board. Yes, you can use encoder. You can use you have an encoder input for the spindle if you need. They say somewhere. I've seen somewhere, because I've been researching a little bit on this board. But I know for a fact you can yep. It's expensive. It's expensive for us, and like I said, I was where they were built. They are built in Arizona. I've been in Arizona, and I should have bought one in there. Anyway, it is what it is, and we have to live with this. It's so yeah, let's go back to, or let's start to work actually. It's been 1 hour and absolutely no work. So let's work. Only thing we've been doing was exercising the tongue. Well, at least I have been exercising the tongue, and you have been exercising your fingers. Okay, so yeah, it's normal on my streams. We go way out of the way. Okay, so let's go to Milo. Functional assembly. Nah, that's fine. That's why we are here. That's what I like about streams, because we can talk about shit. If I don't want to talk, I just do the stuff for myself, and we are not in a hurry anyway. So we machined well, not machined, we programmed the nuts yesterday. We we machined the skirts were the first ones. We did the spindle mounts. Oh, the wakeovers are almost here. So they should be here, like, not sure, let me check. Maybe tomorrow or Wednesday. The wakeovers. I think I called it the skirts, right? The wakeovers, I mean. Ships. So, after customs. Yep, so they arrived today at Portugal, so they should be here tomorrow. They should be here tomorrow, the wakeovers. Okay, we did these. Okay, so let's start with the fun stuff. Let's start with this one. So this is the FF mount for the X. It's gonna be a easy part. Yeah. Okay, so we're gonna start on the top part, or the front part. We only have 2 setups on this one. Thank God. So it's gonna be easy. Yeah, because it's something about that. Yeah, I'm gonna buy one sometime this weekend as well. I need to get some capital in, because it's been only going out and that doesn't work too well. So I need to cash in some. Okay, so same story, different day. Let's go to the manufacturer. Let's create a new setup. Let's go for stock. So XFF, it's this block that I have here. And let's see what shit. The caliper is too small, which means this ruler is also too small. Let me grab a bigger ruler. I should have a tape measure. Oh, yeah, this there. Okay, so this guy has something around 161 millimeter and about 77. Yeah, 77. So we are, well, we are close to that. Let's put a little more, as I usually do. I prefer to have a little more than a little less. I'm putting 0 on top. Wait a minute. I fucked up. Shit, I fucked up these. Why is the stock? Give me a second. Something is wrong in here. Okay, so this is 12. What the fuck is going on in here? Okay, probably... Okay, this is right. Oh! Yeah, I see. Okay, I see. This is because I haven't defined the stock. Let's define the stock. So, the problem here was I was setting the stock already. And so stock side, it means X and Y. And top and bottom, it's Z. And since I have the wrong orientation, it's setting stock to the wrong sides, but let's fix that. So orientation, we're gonna select Z and X as usual. Select this plane, that's fine, we don't need to move anymore. And the middle of the box as I usually do. So now everything is fine. Once, okay, let's remove, yeah, that's closer to my stock, so it's fine. Okay, let's go. So, as usual, let's start with the face. Fuck. I need a pad for my mouse. It runs very poorly. Actually, I should have one. Somewhere. I don't remember. Someone gifted me one. And... But I don't remember where I placed it. Okay, 2D milling face. Let's select the tool. My face mill. 63 millimeter face mill. So the passes should be, everything should be set. There we go. Then what we gonna do? What's this? So this is 9. This radius is 7. Okay, so let's I'm gonna use my trusty. I could use a 6 to machine everything, but it takes longer, so let's go to the 8. Yes, I could use 3D machining in here. Actually, we would benefit because of the chamfers. since this is a big chamfer, it would take some steps there. Yeah, we can do that. Let's do that. 3D machining, adaptive clearing. Let's select my main tool, rough. So we want to machine everything. We just need to go to heights, make sure. Okay, let's go 0.2 lower than the model bottom. Optimal load 2.5. Minimum cutting radius, let's go 0.3. Maximum roughing, so since the part is 12 millimeters, let's do 13. Flat area detection should be fine. Activate smoothing. Go. So now you're gonna see it's gonna machine, try to machine everywhere without us worrying too much. And see, it does some stepping on the chamfer already. Okay, that's good. So let's do the finishing processes. So let's do new operation to the milling, to the counter. Let's start outside. And here. I forgot to select finish. Let's do that. So same story. We go to, can be selected counters. So selected counters, it means it's the level of the counters we selected. Since we selected the bottom, we are good. Let's just add some offset. And activate smoothing. Yes, I forgot to check how can I save that option. Okay, so we have the outside and inside finished. So we need to finish now this pocket. Let's do that. Finish the pocket. Select the pocket. So it should be finished. It's finished now because it's gonna select the same configuration of the tool as the previous we set. So that's fine. We want selected counters, that's fine. We want stock to leave not axial. Actually it's on the floor, it's on the z-axis. On radial, yeah, we can leave 0.1 so we can finish after. On our heights, let's select selection because it's machined already. Let's just give it like 1 millimeter offset. Sorry, selected contours. We could do selection, but we need to select again. Selected contours, it's already there, so you're good. So yeah, we could do plunge instead of ramp. So we go here to the linking, and on the ramp, instead of helix, we say pre-drill because it's pre-drilled already. Oh, actually, I never use pre-drill in here. Usually I use plunge. Let's see. Oh, okay. So in pre-drill, I need to select the pre-drill position, so we can select that one. So it's gonna enter on the middle and do the singy. Now let's do a contour to finish that. To the contour. Here we're gonna select the, everything should be fine. Let's put smoothing in. Let's just select the preferred lead in on this corner. So this will tell the tool to enter in here and output a little further, since we have the overlap in here, finishing overlap. And since this part, so we always want to put the lead in position, so the position where the mill gets in on a curve place, and ideally on an even place. So this part is going to work like that, so the most visible, actually it's going to be filled with a piece inside, but either way, on the bottom it would be more visible, so we hid it there. And we should be fine. Let's do some simulation. We should have everything done except the holes. So first it's do the face, then it does the... Oh, actually, oh yeah, there's a fillet there. Okay. Let me check if this isn't... Yeah, it's not much of a step. So it's cutting a little bit of the wall, that's normal. Now it's gonna finish the wall alone. Did I... Okay, I don't remember if I selected to be very close to the floor. Let me check. Okay, I didn't. So stock to leave, axial stock 005 or 003 and none here. So it's gonna leave 3 cents of a millimeter on the floor and just finish the wall. That's fine. So now the chamfers. Now actually first let's do these counter bores. So for that we're gonna use a 6mm drill mill. So we gotta do boring. Tool 5, rough, finish. And select. Let's do this, select all of them. Now from top height, since we have the chamfer modeled, it's something I don't like, as you guys know, which is something I should change. Anyway, let's continue for now. I think I'm gonna have a problem later, but... Oh yes, I'm gonna have a problem, so let me disable that. Shit. It's gonna mess with a lot of my stuff, I think. But if I disable them... Okay, so what we're gonna do... Let's lock this guy. Let's protect it. Because otherwise it doesn't gonna do this step in here if we remove it. So yeah, let's lock it in position. Everything else should be fine. So let's remove it. Let me just check the length or the size of the chamfers. So it's 4mm and 0.8. Okay, let's remove it. Now it's gonna complain that I selected something. Oh, actually I didn't. Okay, so that's good. The face, it's the same, doesn't matter. Contour is the same. Pocket is the same. This is the same. So if I had removed the... if I hadn't protected this operation, this part wouldn't be cut already. And yeah, it's easier this way. Okay, so let's do the boring. And let's select the 6mm tool. Finishing. Now let's select the pockets. Same. Now I don't have to worry about the chamfer depth. Everything is set already. We should be fine here. Okay. Now let's do the chamfering and spotting and whatsoever. So new operation, drilling, drill. Let me select the spot drill. We're gonna spot first. So firstly, we're gonna let's gonna select all of these. Should be fine. Now on the all bottom, we're gonna select chamfer width. So we usually, so far we always use the chamfer diameter. So the chamfer diameter, what it does is it's gonna spot until you reach a maximum diameter that you select here. But since here on this operation we are selecting two different types of, two different sizes of holes, let's use the chamfer width. So we want like a 0.4. So what this is gonna do, it's depending on the hole size, it's gonna make the chamfer until the chamfer hits that specific size. So that's what we want. We want a 0.4. 0.4 will do. It's probably too much. 0.3. So since those are 5.2 millimeter drills, if I do a 0.4, it will drill up to 6. I don't like that. But if I do less, it's too small for the smaller ones. So what we're gonna do, actually, I'm gonna do two operations. So nope, I'm not gonna select that one. And I'm gonna go to diameter 5.8. I'm gonna duplicate. And I'm gonna delete that one. I'm gonna select this one and this one. I believe these are M4. M4, I'm gonna go to 4.4. Should be fine. Oh, I like to do the dwell here. Need to do that as well. This is just to, instead of going like that peep, soon as it reaches the final depth, it's gonna move out. So I like to do a dwell, so it reaches and it holds it in there for a split second, in this case 0.5 seconds, and then move out. Well, actually that's too much. 4.2, something like that, should be fine. Well, let me check what's the... Oh, actually these are 3 millimeter. Oh yes, these are the FF. Oh, okay. Okay, it would be fine with... So 3.4. Yeah, that's fine. 3.5. Six. Yeah, that's fine. That's a nice chamfer. Okay. Oh, okay. Yeah, that's fine. So these needs to be with a 2 millimeter. Yeah, there's no way I can spot these guys with a 12 millimeter drill since the hole. So yeah, that's fine. So we can do the chamfering of these pieces, all of them, with this tool. But then we need to bring the big boy for the outside chamfer. Okay, so let's do 2D chamfer. Now I need to select chamfer. Let's do all of these. And no, there's no select all on this operation, so we need to manually do it. So everything should be set. Let's do, this is a static chamfer, so the dimension doesn't really matter. Just breaking the edge. Maybe we do the 0.8 that we had modeled before. Yeah, that's fine. And now let's bring the big boy to make the big chamfer. So I believe it's tool 20, no. I don't remember, so let me select here spot all making. Spot drill. So it's 25. And we want to chamfer. Next. So what do we want to chamfer? This guy. And we're going to make it in 2 parts. So it's supposed to be a 4mm, so we're going to do a 3.9 first. Oops, sorry. Here, 3.9. Smoothing. Doesn't matter where it starts or where it ends, because it's just a roughing one. And duplicate. And now we're going to select 4. Hey, why did okay. Okay, when I pressed Ctrl Z to, okay, I need to go back on here before I forget. Yeah. When I pressed Ctrl Z, it actually defaulted to the number and not the expression. So I'm gonna reset to user default, so it gets back to my expression. Okay, and I need on this one to select where I want it to get in and get out. So I'm gonna do it here. So it starts and ends in there, or here would be even better. Let me change that to here. Okay, so let's do a simulation. We should be missing only the drilling. Well, let's do the drilling already. Okay, so drill. So for the 5.2, we have the tool 10, right? I think we use the tool 10 for the 5.2s. Let's select these. Let's make them all. Let's go to whites. Let's go to music because it stopped. What happened? Not sure. There are some little rain outside. Okay, so let's go to heights. Let's go to drill tip true. Not sure if I explained this button here. So basically, if you select an hole and you drill it, it will just put the tip on the bottom of the hole, if you want the drill to come through the hole, you can either go to offset the drill or just press this button and automatically it goes right to the edge where the full diameter of the drill is, and then you can actually add some more to make sure that it actually passes down there. Here we don't have the problem of hitting the parallel, but it's always good to check that. So I'm gonna go, yeah, these are small drills, so we can go full power on them. Now let's create a new operation, drill, and let's select, so those are M3, and M3 for a forming top is a 2.8 drill, and we have the 90, I believe it's 4.6. Have we used the 91? Yes, I believe we did. So let's go for the 92. I'm gonna select it. Do I have a 2.8 here? I know I have a 2.8 set on my machine, but many times I just use like the programming a 2.5 and then use a 2.8 when I need. Oh, we have here a 2.8, so let's duplicate this tool. Edit tool, post processor, number 92, except I believe it's the 92. Yeah, I believe so. A workpiece beneath? What do you mean? I'm gonna hold it on a vise, so it's gonna be in the air actually, and I actually have stock. Oops, let me select holes. Same story, through 1 millimeter, and I actually have stock here. See, we are not even reaching the end of the stock. Not even with this one. Let's check it on the barely, but we are not. So now we need M3 taps on the on here. Let's do that. Operation, drilling, drill. Actually, yeah, that's fine. I'm gonna go deeper on the drills on this one. So select Red Beast. So we have the tool number 11. It's the M5. Tool number 12. It's the M4. So tool number 13. It's gonna be the M3. Same story, select same, and I'm gonna go through 1 millimeter as well, but on this one we're gonna go further. We're gonna go like 2 millimeters or 3 millimeters even. Doesn't really matter. Even if I do the if I drill the stock as I am now I am actually, see, putting down the stock, it will be all in the air through parallels. The parallels will be on the edges against the vice jaws, and they are 8 millimeters, so that's fine. I can do whatever. I can always remove the parallels after setting the stock, but sometimes I have to do that. But this way, even if I forget to remove the jaws, they are safe. Okay, so let's do a simulation. See if everything is as it should. So we do the facing, we do the 3D machining. Let me hide the model. Then we do the finishing the pocket, finishing the wall of the pocket. Do the counter bores. Do the spotting for everything. Do those small chamfers. Now doing the big chamfer. This is the first one. It's the first pass. Then it's gonna finish. Whoa. Okay. Okay, I thought it would be worse. That's fine. So it's just not showing the... We're gonna do it again to see if it fixes it, but it's fine. Okay, it's not changing the stock because of that error, but that's fine. So it's doing the drilling, the second drilling, the tapping, and that's it. Okay, let me save. Before we lose everything. Let's test again. Okay. Fine. Spotting, chamfering, chamfering. Again. Okay. Okay, this can sometimes be because of problems with the in-process stock IPS mesh. Yeah, it doesn't matter. Everything is fine. We can actually, if we want to, we can suppress this operation to check if everything else is fine. It's the first time this happens. I never had that error before. Okay, chamfering, chamfering. Yeah, okay, we have drilling, drilling, and tapping, tapping, tapping. Nice, we are good, so let's unsuppress this guy. Let's recalculate it so it's happy. And we are done with this setup. So the next one is going to be like this. So let's go. Z-axis like that. We want the x-axis to the other side like that. Let's select the model box. Let's go to that corner as I like it. Actually this one, the bottom one. As I like it. Everything else is fine. Let's start with the face. Yada yada yada. Let's select the face mill. Like that. And multiple depths. Seems we are clearing the rest of the stock. 0.2. Let's use even. No stock to leave, no nothing. That's fine. Boom. Everything should be gone. And now it's just some chamfering, cleaning the edges. Have fun. Have a nice rest, Sven. Thank you for showing up. let's go doing some 2D chamfering. Yeah, this is just a cleanup, so first, let me do first spot. Operation, drilling, milling, drilling. In California, it's only 2, so that's 14, 40. It's 8 hours difference for California, wow. Okay, drill. Spot drill. Spot. So I'll just spot these guys to make clean up. 2 diameter. Let's do 3.2. Dwell. Fine. Block. These guys I'm gonna actually do a 2D chamfer for everything else. Chamfer here, 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 here. This is just a touch because we don't want an edge, just to clean the edge. 2.5, 0.2 millimeters. That's fine. Yeah, let's do 0.3. So in here, yeah, it's fine. It's gonna be fine. Smoothing on, go. Yeah, I was thinking that. So in here, so basically it can't do this because the tool is too deep due to my expression of cutting the upper the better. So let's do just 1 millimeter from the tip, and it works just fine now. You guys see? So let's do a simulation of everything. Shit, it's gonna throw that error, right? So probably we need to suppress that. Let's try it. Maybe it doesn't. Okay, so I'll do everything on this side. Oh, actually it didn't. This time. Now, let's see. Spacing, fine. Spotting, see, just cleaning up. Cleaning up everything, and we are good. And we have our part finished and done. Now we're gonna protect everything because I like to show it like this. Now let's create the setup sheets. So let's pose for our picture. Something like that. Setup sheet. Do I have it here? No. Do I have the CNC pen there? Looks like I do. Okay, so I need to go drawings and setups. And Milo. Select folder. Now I need to go there. Shit, it's not there. and we need to change this name. So XFF10 front. The setup sheet is just to create this setup. When I'm machining, it's like a good idea to know, okay, I'm gonna machine this. So it's a good idea. On this case, it's quite simple, but it's a good idea for you to know the orientation of the stock, the size of the stock. When I go to the machine, to the office, or to the workshop, I have a tablet there where I can access these setup sheets. When I'm gonna machine this part, I can go to the tablet and check the setup sheet and see, okay, so the first operation, it's gonna be it's for a production shop, but not only for a production shop. Well, also for you, unless you have like the CAM computer there, or you actually describe each operation. Usually I do, but it's a good reminder to know where is the origin, when you did the programming, where have you done the origin, how to flip, because when you go to machine the second side, you need to know if you flipped it like that or like that. So it's a good idea to have a setup sheet just to check those, to see those parts. And because when you do the machining, yes, of course you can configure the post processor whatsoever. Then you're gonna need the tool 1 first, then the tool 3. But what is the tool 3? Unless you know it by heart, and when you have 10 machines with 100 tools each, it starts to get complicated. So you have the setup sheet that tells you, okay, so the setup 1, you need to set up the stuff like this. So that's the origin. You need to set the axis like that. Then you know which tools you're gonna use. Okay, so I need to set up all these tools on my machine. The description of each tool. Okay, the tool 1, it's the face mill. The tool 2 is the chamfer. The 3, it's the 8mm. The 5, it's the 6mm. The drills, the T10, it's a 5.2mm drill. The T13, it's a 3mm top. The T25, it's a 12mm whatsoever. And then you have the operations, and you know, okay, so the first operation, it's with the T1. The second operation, it's with the T3, and so these will be all together, of course. Then so you have all access to all this information. It's not all needed, but at least I find very helpful. Also, you have the size of the stock. So if you need to go cut the stock, you can go to the setup sheet. Okay, I need a piece of aluminum with 165, 77, 15, or just something a little bigger than the actual part. So you have access to the size of the part as well. So if you don't have exactly this stock, but you know the program is made for this size, but you can also, okay, I don't have 162, but I have 163, or usually you have in bars. So, oh, I don't have a 78 bar, 77, but I do have a 78. Oh, I don't have a 78 or 77, but I do have a 76. Can it fit? Then you go there. Oh, yes, the part is only 75, so I can make it work with a 76. This type of stuff. If you want to check, let's see. Oh, I need to machine. Okay, in this case, it's a simple part, and we know and we take care of to check if we wouldn't hit a parallel bar on the bottom or whatever, or the vise or whatever. But if you're in doubt, oh, okay, when I do this hole, my parallel bar is very big. Let me check how deep the tool that makes these go. And then you can see, okay, so I can go here. Oh, the 8mm tool reaches a Z minimum of 12.2. Okay, so I'm safe. Since my stock is 15mm, the tool only goes down to minus 12.2. That's fine. It doesn't even goes away from the stock. You have a lot of information on the setup sheet. But mainly what I used it for, it's for setting the tools, so to make sure I have all the tools set on my machine. And the biggest, the most important for me, it's actually the orientation of the piece. On the first operation or the first setup, for me it's almost always on the center of the piece, so it's kind of a no-brainer. But then when you need to flip the part, it's important to know how you flip it. So that's, and for me also, this is more for production, to know when I need to machine this piece. Let me check the setup sheet to know what's the size of the stock I need. So that's the most I use the setup sheet for. Okay, so this one is done, so we need that one. So I hope I have clarified why we don't need the setup sheet. It's just something easy to make and very useful to check in the shop. Oops, did I close it? Probably. No, it's here. Okay, so FF back. Let me put the one there. So I know it's the first setup. And the second setup, it's the back. Okay, so this one it's done. And let's go for the next one. So here we are only on the next one. I'll show, well, I can show on this one. So here we are only on the we are only programming. So when I need to actually create the G code for the machine, so it depends on the machine. On my VMC, since I have all the tools preset, I can do like just like this, press with the right button and go post process. Then I select the post processor, which is selected already. Usually when you select the machine, actually here we didn't select the machine, but we can do that. Edit and select our machine. It automatically selects the post processor when you do the post process. It will use the machine configuration, and I have everything already preset. So I just need to select the number of the name of the program I want. In this, usually I use this nomenclature. I just add like front in here, or even sometimes I don't even use. So usually I use, when I need multiple programs on the same setup, I use like the one, it's the number of the setup, and the last one I usually use for the number of the operations. So if I have 10 operations on the setup one, I'll go from 1001 to 1010. And on the second setup, I'll just change the number of the setup. So I'm gonna call it 2001. This is where the output folder where it's supposed to go. The program is supposed to go. On my case, it's for a pen drive, so I can then take the pen to my machine and load the program from the machine, from the USB drive. These are options from the post processor itself, like the sequence, the lines number, the sequence, where do we start. It's kind of advanced stuff. I created this myself for use the ATC, but I'm not using the ATC on my machine. I just changed it by hand. Machining B part, it's also option I did in case, just to make sure I don't hit with the parts on the tool changer, but since I don't use the tool changer, it doesn't really matter yet. Rigid tap EDS because my machine supports it. This is kind very advanced stuff. Optional stop is kind of important. We don't use optional stop. What is an optional stop? Optional stop, it's what it is. It's an optional stop. So it's something you can activate or deactivate on your machine. Usually you have a physical button for that, or if you have a touch screen or whatsoever, you can. It's a button on the controller. Yes, I have an ATC. No, expensive. My machine cost me like 25,000 euros or something like that. So the materials alone. So yeah, it's expensive. I have a 5.5 servo 5.5 kilowatt servo spindle. And if it was now, I would buy the 7.5. Yeah, it's a big machine. It's a 2-ton. It's a 2-ton machine. What else? So about the optional stop. Let's say what? Let's say you were holding. Let's say we were not using a vise to secure this part, this stock. So let's say you made a manual drill here and a manual drill here to. No, it's all made. It's all self-made. It's a cast. Nope. It's a cast. I can show you. Give me a second. Just to make sure I don't have here nothing on my. No, it's all good. Well, just to make sure I didn't add any crazy page here. Okay, so where is it? Should be here. I can place the link in chat. So this is my actual build. So this is the design of the machine. So I have kind of a build log in here. So these are the design for the molds, for the castings. Okay, this is someone else build, which is an awesome machine there. Some of the equipment. So this is the design with the enclosure. Supposedly, it's a little different. It was the first prototype of the enclosure. It ended up a little different. So that is the motor for the spindle. The spindle is here. It's belt driven. If I would do it now, I would do it probably direct drive and with through spindle coolant. This is the spindle. It's beautiful. That's a kidney over here. And nowadays it's very much more expensive. So this is actually how the enclosure was, the final version, with ATC, a carousel. So the actual spindle, the press for the spindle. Venturi for the collets? No. So I built the vibration table for settling the castings. So this is the castings, the test castings I made. So yeah, he's the complete for casting. Yeah, this is a sample of the aggregate. Yeah, this is a casting. Yeah, the first one didn't went very well because the demoldant didn't work as I expected. But yeah, it's fine. It was just not as perfect as I would like. I could have used more vibration. It was the first one, so yeah. But it was perfectly fine. Just a lot of work sanding the how is it called? The wood I used. It's not plywood. MDF. Just glued to the damn resin. So this is the oven for the post curing. So it spent like 24 hours at 60 degrees curing or post curing, doing the hardening. This is the column. The column was I learned, and I basically covered all the wood with the plastic, a plastic film, but like the ones that we use to protect the kids' books, like with self-sticking plastic, and it demolded perfectly. This was it gave me a little more work to do, but demolding was just unscrewing screws and pushing the. So this is the after everything ready to do the casting. Yep. You see, if it's even glowing, it's even like a mirror. The finish, it's amazing. It demolded so well. Even I was surprised how well it went. I only had a little bit there because I fucked up the ceiling, but that's nothing. Other than that, that's like those lines there. It was like the plastic rug in there, and that's a rug from the plastic, but that's nothing. I was very scared about these. So these are the slots for the screws, and it demolded just perfectly. It was just perfect. Yeah, this is a big thing, you know. You see, this is a kind of a big thing. That thing weighs something like 350 kilos, I believe. I have the weights actually written, but that thing, it's super heavy. So this was me machining the piece to hold the spindle, like the jacket. So this is the saddle. Oh yes. So then I went to, this is a factory from a friend of mine. So we could machine the things for the... No, that's not mine. That's from a friend. He machined the things to the guides, or to the rails, to the linear rails for the blocks, the bearing blocks. Everything was machined on that machine center. And this is where it lives now. It's probably where it's gonna die, because I don't think I'm gonna ever moving it. So the oiling system, I had to change this because this sucked. I didn't even mount it on the machine. I didn't got to that, but I had to change that. The end stop adjustments. Yeah, I had to build that structure in order to actually lift the parts to fit to put them on place. The head, the table. I don't have many more in here, then I stopped. Hey Antonio. Yeah, I have more pictures, but then I stopped posting because of work and stuff, but yeah. Yeah, it's a nice machine. I liked very much the end result, to be honest. It was fun. Fun to build. So as I was saying, I was talking about optional stops. So let's say you have a spoil board under or whatsoever, and you just drilled some holes in here. Of course, we couldn't do the same order of operations as we did, but let's say at some point you need to stop your machine and actually use these holes to fix the part in order to machine Yeah, it's a big ass rigid machine. Yeah, it's a proper milling machine. Yeah, thank you. It was a nice build. It was expensive, but it was less than half the price of ordering the same machine, or a machine with the same specifications as that one, especially at that time. It was even less than it was like a third or a quarter of the price back then. Nowadays I wouldn't bother building one, because we have access to maybe better machines at about the same price, or even just a little more expensive. And I wouldn't have the work. It took me months to build that thing, at least 3 months. It was during the pandemic though, so it was kind of good timing. I had everything before the pandemic came. Yes, the learning curve, it's unthinkable. But yeah, it's fine. It's nice. So I was saying, at one point you wanted to, okay, I need to stop the machine to bolt in, to use these holes to bolt in the part. Let's say you wanted to put it here. So after this operation, it doesn't matter, or after the drilling, doesn't matter. This is just an example. So you can make a new operation and a manual NC. And the type, you can put comments. Let's say, okay, I need to add screws. This is a comment. And then after that, I need a new manual NC, and I want an optional stop. So you can move that whatever you want. So in here, after this machine, after this operation, the post processor will add this comment, which says add screws, and then optional stop. Well, optional stop, it's not kind of the best example, because the optional stop, it's optional. It's more like I need to check something after that operation, and to check if it's fine. And if it's fine, you can then disable the optional stop, and the next time you do that, you run that code, if you have the optional stop disabled, then the machine will just ignore the optional stop. That's why it's optional, because you can disable it or disable it on the machine manually when you want. But yeah, it's just something that exists, and it's important to tell that it exists. But yeah, other than that, so post-processing is just G28 safe retracts. Usually it means after the program finishes, the machine goes to the homing position, which for me it's kind of stupid. I don't know, but yeah, it exists. It's an option. Radius arcs, it's to use radius instead of diameter. This is something. Hey man, how are you? Astro Lemonade, how are you, my friend? I'm glad you're here as well. Anyway, then you just need to press post, and it posts. There's nothing too shabby about it. So now the post processing, it's basically the conversion, the thing that converts the language from Fusion to a language that your machine understands. Now these things can be customized, and let's say you use, for example, on my router, Well, I'm not very known, and I only do live streams, but it is what it is. I have what I get, so I don't mind. I just do this for fun. So on my router, it's like a Milo. I need to manually unscrew the collet and whatsoever and put it back. Oh, that's fine. Even the worst wiring. First, your bed won't heat more than 110 degrees. That's the first one. There's no wiring, even the worst ones won't melt at those temperatures. Not at all. Even PVC, the worst wirings, the worst wires won't melt. So you're fine. No, I won't have an ATC on Milo. So on my router, I have to do everything. Yeah, silicon, it's absolutely fine. PTFE, it's absolutely fine. Even PVC wires are fine at those temperatures. So that's fine. That's fine. No worries at all. Nah, that's fine. That's fine. Even on the LDO kit, on the LDO kit, they use all PTFE wires. That's absolutely fine. You're fine with that. Okay, so as I was saying, I don't use any kind of, on my router, any kind of ATC or even a tool setter. I use the old trick with a sheet of paper on it. It's fine. So I have to manually set every tool after. Actually, I have a tool setter, but that's a recent thing, and I mostly only work with wood on that machine, so I don't even care about being too accurate on the tool setting. So basically, what I do is I need to generate a G-code file for each different tool. So in this case, I would need to generate a G-code file for T1, but then we have a bunch of operations with T3. We could select all of them and post-process them all together since they are all the same tool. Then, so create a G-code for this tool, then for this one, then for this one, whatsoever. Yes, you can do even without an ATC. Nah, that's fine. That's fine, Astro Lemonade. That's fine. Absolutely fine. We talk about everything in my streams. Absolutely fine. You can you can interrupt or ask anything about anything here. That's fine. So, as I was saying, you can create, even without an ATC, you can create a tool change macro on either Linux CNC or Mac 3 or whatsoever. So you can post all the code together, and when there's a tool change, your macro will step in. Let's say you have a macro. Usually we use M6 for the tool change, or I think it's M6 on Mac 3. On Linux CSE, I'm not sure. So whenever you get an M6, yes, that's a no-go. What I seen people do with ERs is making using a stepper to do the tightening. I've seen it was kind of a nice idea that the guy pretty much, I don't actually remember how he did it, but I remember he used a stepper to do the tightening of the ER, but nah, that's fine. No, Milo doesn't have auto tool change, not at all. It's manually. But what you can do, you can do a macro using a tool setter on a specific position of the machine, and you can, when there is a tool change, when it detects an M6, it can go something like ZI to, let's see, Z to home position on top, and then do an interface with you, and something like throwing a message saying, please change the tool. And you change the tool manually, so you, or please change to the tool and whatever it's the next tool. So you unscrew that one and you put the new one, and then you press OK. Then it goes to the tool setter and measure the tool set on the tool setter. For that, you need to at first define a variable where you select the difference of height between the tool setter and your workpiece, so you know that the difference, let's say the tool setter is 5.5 millimeters higher than your part, or your zero on the part, because that's all that matters. So when then the machine knows where the tool setter is and goes there and probes the tool on the tool setter and says, okay, now I know that the tool setter is 5.5 millimeters higher than the part, so it sets, when the tool hits the tool setter, it will set the length, the height of a tool to the 5.5 millimeters, because it's the difference between your zero and the tool setter. And then it knows, okay, so now I know the height of the machine, I can continue machining and doing my stuff until the next tool change, where it goes all the way up. It throws a notification. If you can have a buzzer on your machine and it will do a buzz, or will whatever. You can do some of that stuff. And it's not an automatic tool changing, but it's kind of a smart manual tool changing. Yes, you have now, and they are available for a few years now. Some of those VFD spindles that I really like them, because the tool heads are actually cheap. Those ISO 20s. You even have pt3s, but those are BS. There's no need for those type of machines. You have those thingies with with the tool changing, with the ISO 20s, and they cost about $2,000 if I remember correctly, something like that. Yeah, 8 bar, it's normal. But those ATC spindles, they only need pressure to actually release the tool. Or you're talking about making like some vacuum? Nah, I don't think that's the way to go. I would do something like this. ATC spindle. Yeah, something like this. So these are ISO. So yeah, 1000. So this is a lower power though. 2.2 kilowatt. It's pretty damn good if you ask me. Yeah, and these come from Europe, so no more surprises there. So 1600, but they are more like 4Ks. So this is ISO 30, which is kinda, it's bigger. Let's see what we have more from our side of the world. I've seen more. So these guys, 9 kilowatt, shit. Okay, but this is the spindle alone. But this thing is 9 kilowatt. Shit, that's a lot. I've seen some stuff around 2K, like 3.2s, those values. Let me see on these guys from Ratem sometimes have some stuff. Shit, they don't. Oh, EU store. Okay, that's what we want. Spindle, ATC spindle. Let's see. No, that's not that bad. I worked with 2.2 kilowatt for a long time, and I only bought the 4 kilowatt because it was pretty much the same price as the other one, as the one I was using, and I could get it fast. That's why I changed, because I wouldn't see the need of upgrading more than 2.2 kilowatt on my router, but why not? And it was a little better because the one I have, it's actually 18,000 RPM instead of 24K, because we don't need more than 18,000. So I have more torque. That's only why I change it. So even this guy, let's see if we have this guy with a VFD. No, actually we don't. We only have, but I'm pretty sure he sells the VFDs apart. So 3 kilowatt. So yeah, 3 kilowatt, about 2K. And this is pt3, which is a goddamn... Yeah, but I said it's not 4K, as you say. I said it was expensive, but yeah, I know, I understand that. It's even my router, I spend less than well, probably around this, because I have iWin rails and I have C5 ball screws. Yeah, it was a bit more than this, but yeah, I'm just saying it's an option and it's there, and it's not that expensive as it used to be, because this is with I remember them being like 2.5K from China, so you would have the taxes on top of this, and this is actually from UE already, so you don't even need to. It's just that without extra surprises. So let's see this one. So this one it's 5.5 pt3 as well, which is a goddamn workhorse. Oh, so this one it's more. So this one it's powerful. It's more power. It has more power and it's cheaper. Probably this one is air cooled and the other one it's water cooled. Yeah, that's the difference. This one is air cooled, and the other one we were seeing it's water cooled. Water cooled is better because you can run at lower speeds. Without worrying about burning it, because since it doesn't need the fan wind for cooling, so water cooled it's better. You need a pump, but pumps are cheap. And we lost music. So anyway, ATC is a Gucci thing, and Gucci is expensive. Wherever you go, but these things are awesome. I would prefer actually with a ISO tool, just because tooling would be cheaper, and it's way enough. It's more than enough for what we do. Well, actually, I don't know the maximum. Let's see. ISO 20. Okay, I would like to know what's the maximum. So what's the maximum ER you can get with ISO 20? So we have ER 20. Yeah, that's perfect. ER 20 means you can go up to half an inch, up to 13 millimeters tooling. It's more than enough. Yeah. So ISO 20, I believe for that kind of machine, it's more than enough. And yeah. But so yeah, we can use these on a Milo. That's fine, but it costs the same as a Milo kit. So maybe one day, who knows? I am more into, if I go ATC on Milo, I would go different on a different route. I would do something like this. ER32. No, sorry. BT30 powerhead. I think it's, yeah. I would go something like this. Yeah, I would go something like this, and with a servo pushing this. Yep, exactly. That's the route I would do. I would go. Why? Why it keep disabling my repeat? So yeah. Anyway, let's go back to work. Yeah, well, it depends, because you need to add some kind of encoder, because I believe, I'm not sure, I don't know how Linux CNC works, but I don't think it can handle with gears after the servo. So in order to have an accurate spindle reading, spindle RPM reading, probably you would need an extra encoder. Otherwise, you need to use a servo that an high-speed servo, which they are not cheap, which is pretty much a spindle servo. You can't use like a regular servo, because regular servos are something like in the range of 2.5, 3.5K RPM, and 3.5K it's not much. At least 8K RPM is what you want. So yeah, I would need to do some research on that. Anyway, so let me save this and let's go to the next one. Okay, so now this guy, we're gonna need to break this thing in two pieces. So what I'm gonna do is I'm gonna copy these guys, because these guys are the problem. Oh, that's cool. That's cool. If it can, that would be an option then. I know my CNC controller can't. I need to use a 1-to-1 ratio in order for the tapping. I mean for the tapping, because the whole idea of having a servo on a spindle is for tapping. Yes, you get more you get constant torque on all speeds, but that's the main thing, is the tapping. But yeah, that's something. If it can handle it, better. Because you really want accurate reading on the spindle RPM for tapping to work. Because if the speed is off, then the Z is moving on a wrong speed for the tapping operation. But hey, I seen Tormax doing tapping with vectorless with a VFD, so I don't say anything else. So okay, so I'm gonna copy this body. All sensor for what? It should be handled to, it should handle just fine. All sensor. Okay, now I'm gonna create a component from this guy. And I'm gonna duplicate the body here. Oops. Ctrl Z. I need to select this component first. Well, it's a type of So you mean, I see what you mean. Like, so you put a magnet on the spindle and it basically reads a magnet. Yeah, it should handle that just fine. It's just an encoder. But the quad actually, yes, I believe my friend, my friend from Holland that made a meal close to my friend Stefan. That made a meal that it's kind of like mine. I think he used that technique, but he used, what's the system he's using? I don't remember what controlling. I think he's using a Maso. Not sure. Maso controllers are also very nice. They look very nice. Okay, for now. And I think he used that technique. I think he glued, he made a pocket somewhere in the spindle, and for a magnet, he put there a magnet with some glue, and I think his encoder, it's like that. I'm not sure. I'm almost sure it is. Acorn as well, yes. But I want something open source now. So, oops. I need to move it a little closer. Like 2 millimeters closer, not 5. Yeah, Maso is also not cheap. Okay, let's make it. I'm not sure. We'll see. We can mess with these later. For now, I'm gonna disable them. Okay, let's start with this big guy. So let's go to manufacture. Now, something we can do. So this thing looks a lot like the FF10 we just programmed, right? So what we can do is we can copy these setups. So I just select them both. I pressed Ctrl C, but you can right click it and copy. And you can paste them here. Of course, you need to reselect everything. So model, we want this. We want to select the Z-axis. The X-axis is fine. Box point, it's the middle, it's fine. Okay, so let me grab the stock we have for this guy. So this is the XMM, which stands for X motor mount. So I have 162 by 78. So we have 162 by 77, so let's set 0.5. And this thing is 30 millimeters, I believe. Yes, 30 millimeters deep, so it's this chunk of aluminum. So we are good. So now, so this is 27 millimeters. So let me unprotect everything. So first I need to, oh, okay, no need. Okay, so face, it's the same, doesn't matter. So here I need to change tool because my 8mm tool only has 24 millimeters. Here we should be fine because we have this big ass chamfer, but yeah, I'm gonna change for, no, let's try that. Why not? We should be fine. Because these lines should have 23. Yeah, should be fine. Yeah, maybe we don't, but well, we should be fine. So the adaptive is fine. We need to select, oh, actually we don't need to select anything because everything is selected. 2.5, talk to leave, smoothing. Let's 13, no, let's do 16 millimeters because we, no, not 16. So we have 27, let's do 14. So I'm doing always a little more than half. So we have, since we have 27 millimeters, let's call it 28. And, or let's say 13.5 is middle, so let's call it 14. That's what I came with this number. So we are good. Let me check something here. Did I select it? No, I didn't. So okay. So I'm gonna get rid, since we done this one. I'm gonna get rid the what? The chamfers. I'm gonna protect it. And I'm gonna go to the design. I'm gonna select this guy and I'm gonna suppress this guy. So I'm gonna select what I did here. I selected this guy to find the feature that I want, and I'm gonna suppress it for now. And it suppressed a bunch of stuff, but for now it doesn't matter. Manufacture. And yeah, face, it's the same, doesn't matter. So the 2D contours, so of course they don't exist because it's a different model. So we're gonna use this guy and this guy. Rest should be the same because we are not we are using the selected contours as heights, so we should be fine. Pocket, same story. We need to delete that one and replace by this. Oh, okay, we need to select the pre-drill point, which is this one. Then we need to finish the wall. There. Then we do the borings. So we select these guys. Let me check the depth. Since my 6 millimeters is 18 millimeters as 18 millimeter flutes, we are fine. Now this is the spot, and I think we did two different ones, right? So this is the 5.8, yes, so this is for the 5 millimeter ones. And this is gonna be for the these guys. So these guys are M4. and the other ones were M3. So we need to go a little more. Let's do 4.6. Fine. Now chamfers. So these are the small chamfers, which are all of these. And let's do these smallers, 0.6, just because of these short distance here. I'm not sure if we had the same problem in here. We didn't. Sure, man. Thank you for stepping by, Diogo. See you tomorrow. Okay, so we have these chamfers now. Everything should be good. We're gonna do a simulation pretty soon. So now this is the big chamfer. So it's that guy. Edit, same story, that guy. So I'm not messing with anything else because pretty much, oh, I need to set the point on this one. Preferred lead-in position here. Right? Fine. What else? Okay, let me open the nuts because I need to check some tools in a minute. Okay, so now drilling. So we need to drill these at 3.7 and we use the 3.7 in here. So let me check. So it's tool 91. Yes, 91. So okay, this one is the same. It's the 10 millimeter. It's a 5.2. So let's just select this. We can select the same. Okay, this is kind of a longer screw, a longer drill. Should be fine, but let's do deep drilling cycle. Let's do like something like 4 millimeters. I'm doing 4 millimeters on my machine because it's flood coolant. If it was like a Milo, I would do something like 1.5 millimeters. Okay, so here it should be the tool 91. (91) 3.7, which is here. So here we don't need to make the the drill all the way to the bottom. It's a M4, so we're gonna do. So let's select it. We're gonna do something like. So we're gonna go from all top and we're gonna do something like 12 millimeters with the tip included, 0 offset. And we're gonna do 10 millimeters threads, which is more than enough. So we need to select the tool number 12. M4. Here we need to select the thingies. So heights, same story. We're gonna go all top and minus 10. Sorry, 10. And no, nothing here. So I like to check when I do the tapping. I like to check both to make sure Not sure if you guys can see, but see, this is the top and this is the drill. So the drill is way deeper than the top, so you're good. Some tops are, it depends on the top actually. Let me see if I have some top in here. The good machine tops, desktop, no, sorry, front. So I think I have some tops here. Yes, I do. Okay, so this top, as you guys can see, oops, sorry, it has a flat front. So these are the ones that we need to pay more attention. But there are some, let me see, this guy, yeah, this guy. This guy is pointy, see? So on this guy, so when you're measuring in your machine, you're measuring the point. So with these, you can actually, in theory, use the same depth as the tip of the drill, because the point is gonna go actually until the tip of the hole, which has the tip of the drill. So I don't advise to go exactly to the damn tip, but you can go deeper according to the tap type. So it depends. So this one is also, usually these bigger diameter ones are flat, but I have good, very good taps from Goering. I'm not sure if I'm naming it right or spelling it right. Not spelling, but saying the word correctly. And they actually, even the big ones, have a point on top, because they are specific for CNC machines. So yes, you can use them to tap at the same depth as the drill, because they have that extra point there exactly for that, to compensate the tip of the drill. I can tomorrow, if I remember, I can bring one in here and show you. Where is my... Okay, so we are good, so let's do a simulation to make sure we are actually good. Okay, so first facing, then we go for the milling, then finishing. This is the step I'm kind of more worried. I just want to make sure that I don't rub. Yeah, of course. Yes, we are right on the edge. We are good. I started having, I tapped a lot by hand. Now, then after that, I bought a few, quite a good years ago, I bought an electric tapping arm. Man, it was the best machine I ever bought to my shop. I don't know if you know what it is. Damn, that thing was the best tool I ever bought to my shop. I was at the time I was making some devices that used, like, I was making some devices that had a lot of threads, something in a case of 35, 40 threads maybe. And it took me like, I don't know, 3 hours to manually tap all the holes by hand. And with that thing, I went from 3 hours to 10-minute stops tapping. And without, always straight, without worrying about breaking the tap because the thing has a clutch. Damn, that thing was amazing. So it's one of these thingies. So that thing has a servo on it. Yeah, it's one of these. It was a little more expensive than these at the time. Now they are cheaper. But it's basically, let me see if mine is still around. Probably not. But yeah, it's basically one of these things. So M2, mine is M3 to M16. So mine is a little, has a little more torque than this probably. So this thing has a touchscreen. You select the threads, you select the depth that you want, you select the speed. It's amazing. You just press one button and the thing starts drilling. You can do it manually. You don't need it has two buttons, one to go forward, one to go backwards. But if you want to select, if you are doing multiple threads at some specific length or some specific depth, you can go there, you can select the depth, you can do auto, you can do ship braking, so it goes a little bit, it goes back a little bit, it goes then a little more, it's amazing. And since it's always perpendicular, it's fucking amazing. Damn it, if one do a lot of threading, my only shame is not buying it longer ago, but I didn't even knew they existed until I seen a pneumatic one, so air powered, and that's why, oh, those things exist, let me check. Then I found the electric ones which had these capabilities from selecting the depth, the speed, whatever. Jesus, I bought one immediately, and it was amazing. So yeah, that's when I started to pay attention to the tip of the... So this thing, it's been simulating, so far so good. Is that... I'm not sure if I selected that for chamfering. I need to check that. Oh, okay. An error processing the chamfering again. That's fine. So here we go again. So now it's the drillings, that's fine. Okay, so I think I forgot to select to chamfer this line. Let's check. It should be here. Edit. Yep, I forgot. Okay, we need to select that. It's fine. But yeah, that tool, even my father, which is it's not a blacksmith. He works with it does like steel gates and fences and whatsoever, and doors, and it works with steel stuff like steel frames and whatsoever. Worked. When he saw that thing, he saw a video of that thing, and he said to me, "That thing, it's not real. Trust me, you're gonna buy that thing, you're gonna be the most disappointed kid I ever knew." And I was like, nah, I trust it. it will work like that. And he said, there's no way that thing will work that well. And when I got the thing, the first test I made, it was with a piece of steel. I drilled it to 14 millimeters and I grabbed a 16 millimeter tap and I went with it full force with a 16 millimeter, which is the limit of the machine, supposedly. And it cut like butter. It was like jaws down, and we were like a huge sheep curling coming out, and that thing eating through steel like butter. And I was like, no fucking way, this thing is amazing. It was like, damn it. Yeah, my father was like, god damn, that thing is cool. Now every time he needs a thread, he comes to me, hey Bruno, please, just he does the hole on the mill or on the drill press or whatsoever. Bruno, he doesn't mess with my tools. Well, he messes with the manual tools, but all these electronic shit, he doesn't even get near it. He likes to see it, but he doesn't even want to know how to work it. And that machine is pretty much pretty simple to work. You just need to turn it on. You don't need to program anything if you want to do a manual drill through thread through drill. So he could just go there, but he doesn't mess with my stuff. He just go, hey, please thread open the threads for me at this dimension, and he doesn't mess with it. But yeah, it was so cool. I was so happy with that machine. It was, damn it, CNC machines are cool, but that thing was a game changer for me at the time. And now I didn't have my VMC yet, and now even then I use that machine a lot, because sometimes even on CNC parts that I make, I don't even bother opening the threads on the CNC machine. Many times it's I just, unless they are many threads, if they are many, sure, but if they are only a couple of threads, many times I don't even care. Okay, I'll machine them by hand, and I'll go to the sink and bzz, bzz, thread in, thread out, done. And yeah. Okay, moving on. Let's go for the second operation, which is, we want it like that actually. So edit, let's do this guy, and we want the other side, and we want the other point, that point. So this was funny, I'm not sure if you saw, but that point was blue, so supposedly the origin should be there, but it wasn't. Never mind. So everything else is set. Oh, no selected model. Of course, we need to select a model. Edit. This guy. Let's unprotect all of this. So we do Control G for the face, because the face is the face. It doesn't really matter. So here, it's supposed to be the small holes. So let's select them, all of them. And M4 again, so let's go to 4.4, something like that. Let me, yes it is. And then the chamfering. So let's edit. Let's delete all of these. So it's this, and it's this, all of that. Boom, 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 and boom. So the toolpath looked well. So let's do a full simulation. I'm gonna protect it. Okay, well, first I should have tested first, but pretty sure it's all fine. Well, let's hope we don't get the error. Did it die? Yeah, it's syncing. Okay. Fine. Fine. Okay, we passed through the chamfers without getting an error. Let's go to the other side. Oops. Spots. Ah, we don't need those spots. Fuck. Yeah, we don't need those spots because we don't have the holes through. So I'm gonna delete that operation. Yeah, we don't need these because the holes are not actually passing through. Okay, so now here we supposed to get these. I'm not gonna make these holes. Fuck that. So these are for the stock and stop, and I don't care. If you're gonna spend money and using my kit, if you're gonna spend like 500 euros or 600 euros with the ball screws or whatever, I'm pretty sure you're not gonna save 10 bucks for decent ohming system. So I'm not gonna make those, but I will make these. So let's create a new setup. Jesus, what's going on there? Z-axis and X-axis, let's do that. Let's do, that's fine. Model, it's this guy, that's fine. So I'm gonna go for the stock model box and that corner because it's a corner I like. Stock, I'm gonna say the stock, I'm gonna select the solid, and I'm gonna actually select our model like that so it doesn't mess with us. And new operation, 2D milling, drilling, sorry. Let's do a spot drill first. Red beast, spot, actually it was selected. Hey Beanie, welcome back. So I guess you are at work already. And it should be calm since you're here. What we want, chamfer diameter. I believe these are M4. Actually, I have the sensors somewhere in here. I think they are here. No, yes, they are here. So we can take a look. Let me check. Oh no, actually these are 3.6, so they are M3. That's fine. That's fine. M3, so we go to 3.6. Yeah, sure, man. You can always check the video later if you want. Okay, we do it like that. And now we drill it. Drill. So I believe we have the tool 92 for 2.8. Yeah, exactly. Which is the forming it's the size of drill for a forming top. So what do I need more? Drill, that's fine. Let's do drill, deep drill. 1.5 millimeters, fine. And top, new operation, drilling drill. Select. Let's do the tapping we have here. Did I select? No, I didn't. Yeah, and I'm gonna do an offset of something like 1, because we don't need deep threads for this. Let's see. Yeah, that's fine. And yeah, we are done. Let me protect everything so I can reactivate the design, so I can unsuppress features. So we can create the setups already. The setup sheet, sorry. What is not? Oh fuck, I forgot to protect our... I'm gonna protect it now. Fuck. Okay. Let me do this. I'm gonna protect this one, and I'm gonna protect these ones. So, why are you giving me an error? Okay, let me do this instead. Okay, let me recalculate. Yes, yes, and now I'm gonna protect it. Fine. And now I'm gonna go there. I'm gonna unsuppress this guy. And gonna go back to manufacturer. And let's go. Let's create the setup sheets for this. Pose for picture. So setup sheet. Select. Shit, I closed it. So I need to go there again. So this is the X motor mount. Let's call these, let's rename these actually. Let's do X FK10 1 front. I see I have a typo here, and I'm gonna copy this. Oops, this is not what I want. This is okay. Let's do the setup sheet on this one. Okay, let's do 2 back. And oops, I forgot to, okay, I need to remake this one. I forgot to reorient the picture. It would be fine, I could see perfectly, but it's way more visual if we do something like this. I advise when you work with didn't I deleted it? I thought I did. I advise you to, when you work with CNC machines, to be as clear as you can on everything. Try to do the less brain usage you can, because it's exhausting. And when you do mistakes on the Milo, it's not a big problem because you can't actually do expensive mistakes. But when you work with big machines, shit gets expensive real fast with stupid mistakes that sometimes it's like, even when you do math on your head, like calculating coordinates or whatsoever, double check with that damn calculator, or triple check even in your head. And at the end of the day, it's when you are more tired and whatsoever, it's easier to make mistakes. So I always keep a calculator. I'm quite good doing math on my head, but when I'm calculating like the center of a piece or whatsoever, I tend to actually use a calculator to make sure the data is correct, because yeah, I can't tell you how many times that I facilitate something and shit goes bad real fast. So I really advise you to write as many notes as you can, like if you're even if it's for yourself, the more clear you get, the better. The less input, the less human input you can get, the better, because machines don't make mistakes usually, at least 99.9999999% of the time. You tell the machine to do the mistakes. So yeah, these setup sheets are very helpful for that stuff. So you don't need to overthink or whatsoever. That's my input on it. On my machine, you'll see I have actually a calculator on my. So it's kind of sad. One thing I don't like on my CNC controller, on my big machine, and I'm used to Mach 3, and Mach 3 you can actually, as I do on Fusion, you can actually do math on the fields. So if you're calculating center of the x-axis, for instance, so you probe one side and you're gonna probe the other. So you probe the first side and you zero, then you go probe the other one and you need to divide the value on the arrow by 2. So on Mach 2 you could press it and press /2 to do the division by 2 and press enter, and it would it would divide the value by 2. On my CNC controller it doesn't work like that. If I write /2, it doesn't do the division, so I always need to calculate and input the actual value. So that's the only thing I would change if I could on my, or one of the few things I would change on the controller on my machine. Linux CNC, I'm pretty sure if Mach 3 can do it, Linux CNC pretty sure can do it as well, especially with a touchscreen. So, but yeah, a calculator, it's something that it's very useful next to a CNC machine. So on my controller, I actually have a calculator on the controller. Okay, so setup sheets are done. So these are for the this part. Now we have the, oops. Now we have these parts we need to machine as well. And again, I'm gonna machine them together. So I'm gonna do it both at once. So let's create a setup. Now we're gonna select this body and this body. Let's select the stock. The stock we're gonna do relative size box as usual. So let me check, what do I have? So XMM. So I pre-cut these. Let's see, I have 130. Shit, that's way bigger. Okay, so I'm gonna do increase the space in here at least 1 millimeter or 2 millimeters. Looks good. So it's gonna be 128. So let's set 1.5. Should be fine. Okay, let me reorient the thingy. So we want this as Z, and well, it's fine like that. It's 15 millimeter stock, so we should be fine. 0 on top, and on bottom we have. So my stock is about 43 millimeters. High, so we can add something like 5 millimeters on bottom. Yeah, that's fine. And we should be fine. Let me just increase the space between them. So I'm just gonna move body to 1 millimeter on this direction. The fuck? 1. I moved it 1 meter instead of 1 millimeter. 1. Yeah, 2. Let me see how far are they from each other. So minimal distance, yeah, that's 1 millimeter. Is more than enough. Move. How far are they like that? Well, they are far enough already. One millimeter. That's it. Okay, manufacture again. So if we go here, the stock should be updated. Yeah, we have 128. I think we have 130 in here. Yeah, a little less than 130. We are fine. Machine can handle that just fine. So in this case, we have a lot of more on Y, but that's fine because my stock is 15. So I'm working, so the bar, I bought it like that, but I'm gonna work actually like this on a vertical. We could go, instead of relative, you can add stocks to all sizes. Where is, well, you used to. Oh, here. So it's a relative, it's still relative, but here on stock offset mode you can do it to all sides. So I can say I have 1.5 millimeters on X minus, well, 1.5, not 1.5. 1.5 on X plus, 1 on Y, 1 on, or in this case, 0.5 on Y, 0.5 on Y plus, and Z 5, right? Yes, 5 on Z minus and 0 on Z plus. So you can create your stock as you want. So in this case it would be even more like this and this. So yeah, pretty much how you want. So on this case I'm not going to use a face mill because it makes no sense. We only need to face this piece and this piece. So, and this thingy is like I said, what's the length of this? Oh shit, 26. That hurts. 15 millimeters. So what I'm gonna do, I'm gonna use my my long 8 millimeters. Well, first thing, let me get rid of the chamfers because I'm pretty sure. Oh shit. If I suppress them, will I? Oh, okay, fine. Okay, so I got rid of the chamfers. And let's go. So I'm gonna use a facing operation as well. But yeah, I can use a facing operation. So what I was thinking is, will I face the whole thing or will I machine it first and then face just the pieces? It's gonna be faster if I do only the pieces, but not that much faster. We're gonna save like 5 seconds of machining, but that would be the efficient way to do it. So let's do it that way. So first we can do, well, we can take advantage of the 3D milling again, since we have several levels whatsoever. So let's do that. So I'm going to use my tool number 7, which is the 8 millimeter flat long. I'm going to use rough. So this thing has a 35 millimeter flute length, so we can do 35 millimeters at once. So yeah, that's fine. Lowest level top model top bottom minus 0.2. So we make sure we go under the model just a tiny bit. Optimal load, since this is a long mill, I'm gonna go a little slower on it. Or did probably Marcus? Yeah. So 20, I think these things are 37.5, so 38, so let's go 19 mils. Fine steps, that's fine. It should be fine since we have the flat area detection. The only concern here, it would be so you get a step as close as this height in here, but flat area detection is exactly that. It's going to detect there's a flat area here on this level, and it's going to do a step down or a step on that thingy. Let's activate smoothing and let's see what it does. Okay, it should be fine from what I'm looking. Will it? Yes, it will. So yeah, it looks good. And now we can do the face. Oh, so create face. and we select these two contours, so it will just face these two, or enough to machine these two surfaces. Then let's start doing the finishes. So as I said, this piece is 37.5 millimeters height, and my mill, it's only 35, so I can't machine this surface all together, right? So what we're gonna do is we're gonna create a finish here first. No, they are the same. Well, now that you're talking about that, you probably... Yes, you're right. You're right. Good point. Good point. I copied it and I shouldn't have copied it. Good point, my friend. Good point. So this guy... this guy is gonna die. Delete. Good point. Glad someone is paying attention. So what I'm gonna do, I'm gonna create a mod. Someone is paying attention. So I'm gonna create this guy here. Oh shit. Where is it? Yeah, it's here. And I'm gonna create a mirror. Object, this guy. And mirror plane, can I select it? I can. This guy. And how far are we? Probably a little bit too far. We'll see. Manufacture. Let's go. Edit. Yes. We need to select this guy as well. Let me see how far. Okay, I am a bit too far. Let's move this guy. Edit feature 32 instead. And we should be good. Edit. Dock. Yeah, we are good now. Good point. So this is the same operation. Since it's the 3D, it's gonna look at the pieces, not at any selections. So we're good. Face. We need to reselect. Yes. Since this guy disappeared. So let's select this and this and this. And let's go back. Yes. Clear. So we're gonna create a finish pass on these two. Now we need to move the height. So the top height it's fine, but the bottom height it's not selected contours. We can do either. Yeah, no, we have to do selection. There's no either. So we can do here. Now we need to do a finish. This is a finish pass. So stock to leave. So here I'm gonna do a negative stock to leave of minus 0.05. So that means it's gonna cut slightly smaller. So when I'm gonna pass on this one, I'm not gonna rub here on the on this piece. Actually, I'm gonna give it a nudge more, like 7. And on the axial, the axle it's not really important, but we want to leave, since we have 0.2 millimeters from the leftover from the 3D adaptive milling. Let's give it 0.1 offset, and we should be fine like this. Let's select the lead in position. Can go here. Yeah, that's fine. So like that should be fine. And now let's do another one. New operation to the milling to the contour. That. Smoothing. Stock to leave. Oh, let's not make stock to leave. Let's go to play with the heights. So we have the selected contour. That's fine. Let's do minus 0.1. Make sure 0.1. To make sure we go under the part. It's gonna be fine because we need to chamfer that, but yeah, that's better. So let's do a simulation of what we've done so far to see everything should be fine. So this is the 3D milling adaptive. Then we do the facing. Then we do the finish of that pillar. Let's call it the pillar. Then we do the next one. And then we do the finish here, and we should get a little step there, which is exactly what I wanted. See? So the tool doesn't rub on that part. Okay, we still need to finish the floor in here. It's not super important, but let's make it beautiful. So for that, I'm going to create operation to the milling pocket. I'm going to select this, we're going to select this, I'm going to select this, and this face. And we are finished, yes we are. Stock to leave, radial stock, we're going to leave 0.1. And axial nothing, smoothing move, and this is weird. Oh, okay, I see. I see. Let me reselect it. So I'm gonna select this guy, this guy, this guy, and this guy. That should be better. Let's see if it finishes everything. I don't feel like it. Increase speed a little bit. Just want to make sure, yeah, it's not finishing everything as I suspected. Okay, so this is a interesting thing. So the only problem in here is because I don't even know what's his problem, but to be honest. Okay, let me do this in 2 parts to see if it works. Or let's do... Okay, so if I do this and this, it should work fine. Yes, it works fine. Okay, let me duplicate the tool. So that's fine. So let me figure it out. Why aren't you doing this one? Because of the goddamn hole. Because the hole is splitting the surface. And if I do this, what will you do? You'll do way more than you should. Okay, so what I'm gonna do in this case, I'm gonna shit a little bit, and I will mess with these screw holes. Well, fuck, because I designed them on the... God damn it. Okay, it doesn't matter. So we can start from offset, and we go either 1 or -1. Everything I modify mirrors to the other part. So if I modify here, yes, I do. It does. Okay, so it's the other way. So I need to do offset -1. Oh, no, 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 no. I see. I see what I did. Okay, so what I did, I need to roll back the history here. Okay, this is fine. Edit feature. I just need to move in the screw holes as well, like that. Now I'm going to create the holes on this side. So this thing is supposed to be... I should have checked. I think it's 3.7. Well, I have an EMMA here. Pretty sure this thing takes 4 millimeters. Yeah, I think it's 4.6 or whatsoever. Oh, actually it's exactly 5 millimeters. Yeah, but 4 millimeter screws are fine. Why Fusion doesn't like me? Okay. No, I fucked up. Give me a second. Okay, this guy, edit. The only thing I don't want is you and you and you. But since I'm here, okay, so I made the things for M5 screws. So we're gonna use M5 screws. Okay, see, where is the... It's here. So 4.6 actually. Well, I'm gonna call it 4.2 because I've been using 4.2 every time. Yes, and here, but not here. 11.9. So yeah, everything else should be fine. Shouldn't have any problems. And now I don't have that surface there. I could do a patch. Actually, I can do as well. I can do that fix as well. So manufacture now, it shouldn't be a problem. I'm gonna recalculate everything. And it shouldn't be a problem if I just go here. Actually, I'm gonna delete this one. It shouldn't be a problem if I go here and just on the surfaces select this guy and this guy, because the hole is not there anymore to fuck these things. And yeah, see, now it's fine. So don't ask me why, but Fusion doesn't like the hole there. So yeah, we can fix it. So this is one way to fix it. Other way would be go to the design. So I'm gonna make the holes again just to show. This is something we usually I need to select this guy. Edit. So let's do the 12. So now we are back with the what's there. That's fine. So another way to do this is in the surface. Now I know this can be done. I'm just not sure if I'll be able to do it because I'm not an expert on this thing. Do a patch. Like that. And that. Yeah. So you could do this. This basically it's a skin, or it's a no thickness surface that we can use to sheet sometimes on cam. So we do another one in here. So we do another patch and we select everything that we need till it closes, and it creates just a no thickness surface in there, and you can use that to. If I go here, now I'm gonna get the mistake. Actually, this is the best solution. It would be the easiest. I just wasn't sure if I could do it easily. So now you would just select same story. We can select that. We can select this, and you would select the skin instead of the surface. Yeah, it should be fine. Well, actually, it wouldn't work, looks like. Let me see if I did it like this. Oh, I think like this it should work. I'm not sure. No, these won't work. Let me try like this, just to see. Nope. Well, I could do that, Beanie. I think I could do that. But that eliminates the point that I was trying to join. Like that. So I assume that's what you were saying. So I created a patch and thickened it. But yeah, my idea was using just the patch. And use the patch as the guide. But it doesn't seem to like it very much. Edit. Yeah, whatever. So we solved the problem with the whole thingy. I'm just Control Zing until we're done. So yeah, the holes are not there anymore. That's just because it's really shallow. So it kind of shows there. That's kind of a bug, but that's fine. And now we can select the pockets. But yeah, you could do what Vinny said. Thicken the patch and join it to the model in order to close the hole. Or you can just do what I did and change the depth of the hole and whatsoever. Okay, that's fine. I like that. Doesn't matter because we're gonna need to drill these from the other side anyway, because it will intersect with this corner here. Yes, I could do this corner bigger so it would pass, but doesn't really help. And we need to machine the other side anyway, so we are fine. And what next? Yeah, it's time for me, after we finish this part. Okay, so we finished everything. So let's go to spot and drill and do the other and chamfer. So new operation to drill. Let's select the spot like that. Spot, go, 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 go. Actually, I'm gonna spot these as well. These I won't. This is just for the appearance. So what more? So in heights we go to chamfer diameter. 5mm should be fine, since these are those are M5, right? So let's do 5.4. And well, as I like. Oh, okay, it doesn't let me select those. because they are on the other side of the stock. Fuck you then. You don't like them. We don't care. Let's do just these ones. I thought it. Ah, okay. It does, but yeah, it's gonna be bothering more than, yeah, it doesn't matter. I'll just give them a, let them be. So now chamfering. 2D chamfer. This is just edge breaking. It's not actually a big chamfer. So, well, what do we need? Like 0.3 millimeters. That's fine. 0.1, so we can get as close as we can as at those corners, and no linking. Oh yes, I need to select the chamfer here. Yeah, and now it's giving. When I forget to select the chamfer here and gives me that error, it will keep me. It will keep giving this warning that the feed rates are 0, even when they are not. It's a bug. There's nothing. When I restart the fusion, it will be fine. But yeah, it's fine anyway. So let's do a quick simulation. It should be all good. It's fine. So do the pockets. Spots. The chamfers. And we are good. So we can flip the part. Exit simulation. So we're gonna flip it like this, because these things are round. Well, this is fun. So now, so this is a fun part. So when we flip this, since this is rounded, it's gonna be kind of sketchy to get a reference for the X. So we have a couple of solutions here. First one, I can easily, with my hammer, just probe find the most to the left spot or point on this circle, since it's a analog probe, which is what makes it amazing, or one of the things that makes it amazing is that. Or we can use a known spot like this corner here. For that we need to use something like a spacer, like a parallel, for example, in here, to offset this dimension, or this surface. Actually, that's what we want, offset it to here. So yeah, that's probably what we're gonna do. So for that, I'm gonna go to the design. I'm gonna create a sketch in here, and this sketch I'm gonna extend that line, and I'm gonna extend that line, Why the hell did my other line disappear? Okay, we have two. This is important. We have two. We want this one. And we want this one. Like that. I'm gonna finish. So that's gonna be our origin point. So this setup is done. We need a new setup. Stock is from previous stocks, from previous operation. That's fine. Now the stock point, the origin. Well, first the orientation. We need that and X for the other side. Now for the origin, we want to select a selected point, and that's exactly why we made that sketch, so we can select that point. And now our origin is going to be there, so we can probe this face, and we can use a parallel to offset this surface and probe the parallel, and we know we're going to be offsetted by the size of the parallel, and that's fine. Okay, we need to select the models, so this model and this model, and we are good to go. So again, we are not going to use the face mill here. We're going to use the my trusty 8mm mill for this guy. Actually, let me check something. So these to here, 22. Okay, so we're gonna use, actually, to save one tool change, we're gonna use my 6mm mill, the long one. So we're gonna do, to clear these 5mm of stock on top, we can use an adaptive clearing. What we're gonna do is, I believe, I'm not sure, they changed this. I'm gonna select stock contour and this surface. No, sorry. So I'm gonna select this, but in here on pocket, I'm gonna select this surface. So this is what does this? So this lets Fusion know that we want to adaptive clear this section at this height. At least I think it's like this. They changed this a while ago, and since I used the face mill, I haven't used this kind of strategy to remove the top stock as often as I used to, but I'm pretty sure this will work. So this is a long mill. I'm gonna lower the optimal load. And yes, I'm gonna leave 0.2mm as usual, activate smoothing, and yeah, exactly. It works exactly as I was expecting. So it will adaptive clear the top. We can simulate that. It will just remove the top stock as we want, and now we can face it to remove the top. You don't understand? So I'm gonna probe. Okay, let's go. So what I'm gonna probe is this face in here, or the vice jaw, because we have to understand. So in theory, I'm gonna, not in theory, in practice, I'm gonna have, let's simulate, this is the, am I on the right plane? I am. So I'm gonna have this is the jaw of my, this is the jaw of my vice, right? Let me put it to size. Just this one, 150. So it's gonna be something like this. And I'm gonna have a parallel under here. So I'm gonna make a line in here. That will be collinear with this one. Finish. Fuck. E. Y. Fusion. That's fine. Okay, let me do a rectangle. Doesn't really matter. That's collinear there. My parallel is gonna be like this. Let me do it -8. And I'm gonna create another body. Okay, so this is gonna be pretty much something like I'm gonna have set up on my machine. So this is the vice. This is the parallel where the part will be sit on, right? Okay, so we're gonna have a piece of stock on top of this, right? Let's go to the manufacturer. So after this operation, we're gonna have, like, on this case it's not relevant because it's so thin, but yes, it's gonna be there. Okay, so if I probe the face of the vice, I'm gonna get the Y, right? And if I probe the top of the parallel, I'm gonna get the Z, as you written, right? And now we need to probe the the X. For the X, what we can do is actually, let me check how much do we have here. Yes, that's fine. What we can do is put a parallel like this. Let's say it's a 10mm parallel. And let me project this. So we make it collinear here. $4mm, which is one of my parallels. Exactly. So this parallel, it's 10 millimeters, and this way I can probe this surface is outside the round circle or the rounded part, and I can just probe this part, and I know when I'm 0 in here, I know I am 10 millimeters off the I'm 10 millimeters off the my 0. These are tricks that we use sometimes. So as you see, a parallel set, it's something that's pretty much essential. You can use any other stuff as long as it you know it's flat and you know the dimension. So you can even use, I many times use something like a magnet. Yes, of course, I could drill like these one of these drills the full way, all the way into the top, and then I could probe the hole. Yes, that's something we could do, but it's a goddamn big hole, and drill a twist drill. Drill a hole with a drill. It's not that well. It would be just fine for this application. It wouldn't be, but it's not ultra precise. But yeah, that's something we could do. But yeah, this is the usual. On my case, I have plenty options. I could, since my hammer is analog, I could just swing the probe around across these rounded surface and find the as an indicator, because the hammer pretty much is a 3D indicator. I could probe and find the eye spot. And the eye spot, I know it's the maximum X, which is exactly what we want. It's to find the maximum X, and would be fine. Or we could do this, as I did, since we have a flat here and a flat there, or in this case only this one, it matters. So we can just use something we know it's accurate, like a parallel, and probe it from there, and we know we are X amount in offset. So anyway, so we machined the top, we machined the face. Yep, exactly. I'm very used to my hammer, which is not automated at all. It's pretty much very manual, and to be honest, I love it. It's super expensive, but yeah, it's very useful. So I'm doing all these kind of tricks all the time. Okay, so we do the removing the top. We do the facing. Now we do the boring with the same tool. Bore. Finish. Simple. Oh, I need to change the face as well to finish. Okay. So we do the boring. Go down. And yeah, all we need is chamfering. Oh, and we need these guys. Okay, so now we're gonna do drill. And we're gonna spot these guys. And I forgot to select the tool. Select the tool, spot. So these are M5, so we're gonna spot to diameter 5.8, 5.6, it's fine. Dwell. Okay, so let's do the chamfering now. Again, chamfering, it's only edge breaking. So we're gonna just do something like 0.3 cut, 0.3. Since I'm pretty sure we're gonna have a problem there, I'm gonna decrease these valve. Fuck me. Let's go chamfer. And we only need now to drill and tap those guys. So new operation, drill. So we're gonna go with a 4.6, which is tool 90, I believe. Yeah, I'm pretty sure it's a tool 90, right? For the M5. Where did we use the M5? Here we did. Okay. Need to select. Same diameter. I'm gonna go. Fuck. Okay, I can't use the same diameter because it's gonna select the other ones that are already done. So I have to select manually. Cut through. I'm gonna give it a little nudge more, just why not? Okay, let me check just which one is, I think it's here, right? So 91 is 3 point bottom. Yeah, it's tool 90. Tool 90, it's the 4.6. That's fine. Tool 90, that's fine. And drill, select beast, top M5, it's the tool number 11. Like that. And we should be fine like that. Tapping, that's fine. Now here, yeah, that's fine. That's not a deep drill at all, so we should be fine going all the way. Full force. Full power. Okay, let's do a simulation, but I'm pretty sure we are done. So that side we are pretty much settled. We know everything is fine. So here, first we remove the top. Then we do the facing. Jesus, fusion is so... Wait. Oh, okay, that's fine. Then we do the boring. Then we do the spotting. Then we do the chamfering. Then we do the drilling. Then we do the tapping. And we have our parts done. So let's do setups for these thingies. Let's pose for the picture. I'm not I'm actually pretty sure it will appear. What is this body? It's that one. Let me remove the constructions. Yeah, like that. So setup sheet, go, contain errors, post, oh, fuck. Okay, I need to redo this. What's with you? It's fine, fine. Okay, let's redo. Setup sheet. There. So now here we gonna call it X motor mounts. Because they are indeed the motor mounts. One top. Yeah, that's fine. And the second one so here I'm gonna make it really visual, the sketch. I'm pretty sure the sketch is gonna appear there as well. So we're gonna do setup sheet, same. See, we're gonna have it there. Even the sketch I made is gonna show up on the setup sheet. And we're gonna call it 2 back or bottom. And yeah, we're gonna finish today in here. So we have a few more pieces done. So this one is done as well. And also this one. So we are missing just a few more. So we have the Y float, Y motors, Y motor mounts, and the Z ones, and the sensor mounts, the end stop mounts. So yeah, we are going well. Couple more days and we're gonna have everything programmed. So we can go back to the Micron, finally. Well, actually, we can go back to the Micron anytime, as soon as I print everything else I need, which I'm gonna do hopefully in the next couple days. But yeah, we are done for today. I'm gonna get some sleep. 1.5, Jesus, already. Yeah, that's it, guys. You're starting to get into the thingy. That's cool. That's cool. So that's the idea. It's for you guys to learn something new. So that's it, guys. Good night, Mini. I'm gonna finish here. So we have a lot. It's gonna be a fun build, this one. It's gonna be a very long one because there's a lot of stuff we're gonna try. The idea, it's gonna be as to try as many options as we want. So we have we have the factory motors to try. I'm pretty sure I'm not gonna try them. It would be fun to see the difference. of the factory motors and these ones, but I'm not sure if I'm gonna lose time. One thing I'm gonna lose time for sure, it's with Linux CNC, try the parallel port because it's way cheaper. Try the parallel port first and see if it works well, and then move to the God damn it, I'm itching my nose, and move to the Mesa, which is the very best option. But yeah, we'll see. That's kind of an experiment that's not really that much that doesn't take too long, but it's gonna take some time. So we're just gonna need to see if it works well enough. But yeah, so anyway, that's it for today, guys. Thank you for watching. If you guys like and subscribe. If you guys have any questions, please comment below. Join us on Discord, link in the description. Again, very thank you for the Lab 4450 for supporting my streams, whichever if they are about 3D printers or not. So they are very nice. Thank you, and have a good night. See you guys tomorrow. Thank you again. Good night, guys.